Okay, in this video we're going to look at questions 8 and 9 on the worksheet. And question 8 says, we'll show in section 10.4 that e to the x is equal to this series 1 plus x squared over 2 factorial plus x cubed over 3 factorial and so on. And this series converges to e to the x for all x. And note that we can write this series using sigma notation where we're summing x to the n over n factorial in the index n starts at 0. Now it says, use this series representation to show that the derivative of e to the x is equal to e to the x itself. Okay, now this is a fact we know from Calc 1 and Calc 2. And we're here going to derive this fact by differentiating this series term by term. All right, so we can start out by just noting that since e to the x is equal to this series for all x, if I want to differentiate e to the x, I can then differentiate this series term by term. And so we can go ahead and do that. The derivative of 1 is 0. The derivative of x is 1. The derivative of x squared over 2 factorial, that's 2x over 2 factorial. The derivative of x cubed over 3 factorial, that's 3x squared over 3 factorial. Then we get 4x cubed over 4 factorial, and so on. I want to point out here that since this original series for e to the x converges for all x, okay, this series we get here by differentiating term by term, it will also converge for all x. Now we know from our main result on differentiating and integrating series, it is possible, right, to have the convergence at the endpoints of the original interval of convergence to be affected. However, since our interval of convergence here is the entire real number line, there are no endpoints to be concerned with. Right, so this series also converges for all x. Okay, so the other thing I want to point out is that we can simplify these terms here by just making the following observation, right? 2 over 2 factorial, which we see right here. Well, that's 2 over 1 times 2, right? The 2's divide out, leaving us with just a 1. 3 over 3 factorial, you see that right here. Well, the 3's divide out, leaving us with 1 over 2 factorial. 4 over 4 factorial, well, the 4's divide out, leaving us with 1 over, and then this is a 3 factorial, so on and so forth. Okay, so this series then is equal to 1 plus, this is 1x, so just x, plus, so 3 over 3 factorial, that's 1 over 2 factorial, so this is x squared over 2 factorial, then we get x cubed over 3 factorial, and so on. And we recognize that this is just simply the series for e to the x, and so we are done. The derivative of e to the x is equal to e to the x itself. All right, cool. So now let's go ahead, check out question 9. Here it says, it can be shown that the sine of x is equal to x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial, and so on. And this can be written in sigma notation where we're summing -1 of the n. That gives us the sign change. The exponents on x, these are the positive odd integers, so we have an x to the 2n plus 1. And then downstairs we're taking the factorials of the positive odd integers, so we have 2n plus 1 factorial. All right, and this series converges to sine of x for all x. It says, use this series to find a series representation for cosine of x, and then it asks, what's the interval of convergence? All right, well, pretty similar to what we just did in question 8. First note that the cosine of x is the derivative of sine x. And I know, right, I'm given in this question that sine of x is equal to this series for all x. And so I can differentiate then this series term by term. And so that's going to give us what? Well, the derivative of x is 1. The derivative of x cubed over 3 factorial, that's 3x squared over 3 factorial. Then differentiating x to the 5th over 5 factorial, that gives us 5x to the 4th over 5 factorial. And then minus 7x to the 6th over 7 factorial, and so on. And just like what we saw for e to the x, right, since this original series converges for all x, okay, this resulting series where we differentiate term by term, it also converges for all x because there are no endpoints to be concerned with, right? Our interval of convergence for this original series is the entire real line. Okay, note we could also say that the radius of convergence for this original series is infinite. Okay, and we know that if we differentiate or integrate term by term, that does not change the radius of convergence. It'll still be infinite. Okay, so this series converges then for all x. And also, just like what we did in question 8, we can simplify these terms as follows, right? 3 over 3 factorial, that's 1 over 2 factorial. 5 over 5 factorial, that's 1 over 4 factorial. 7 over 7 factorial is 1 over 6 factorial, and so on. And so we arrive at this series representation for cosine of x. And it's 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, and so on. Okay, so we record that result here. And I can write this series using sigma notation. Here I'm summing negative 1 to the n times x to the 2n all over 2n factorial. And n here starts at 0. All right, cool. So that's going to do it for this video. Thanks.